So, hi everyone, thanks for being here this morning. Um, ah, is it okay? Yeah, okay. For now, I'm taking you to the Boreal region in northern Quebec in Canada. The Boreal region is dominated by peatlands, which are wetlands in which large quantities of peat or organic matter is accumulated over time because water saturation is reducing the degradation of plant residues. Peatlands are also renowned for their ability to store large quantities of carbon. However, with our growing demand for energy and natural resources, the road network in Quebec and around the world is expanding northwards, and many roads are thus built across peatlands. It's with this context in mind that we're now conducting a research project to assess the impact of road construction on Boreal peatland. And more specifically, we will be studying the effect of roads on hydrology, on plant community, and on process involved in peatland carbon sequestration. The study area is located in northeastern Quebec, so just here. And we sampled nearly 20 peatlands along 200 kilometers of roads. And in all cases, the road was built perpendicular to the peatland flow. And these peatlands generally have a peat thickness of about 2 to 3 meters accumulated on a sand deposit. In this peatland, we continuously monitored water table changes using piezometer installed on either side of the road, so upstream the road and downstream the road. And we also characterized a plant community on plots located on transect across the road at distances of up to 100 meters from the road. The analysis of the influence of the environmental variables on peatland species composition pointed out the predominant effect of changes on peat chemistry that was assessed by conductivity and pH measurements. And in response to these changes, plant community close to the road shift and were transformed and become very different from the community located at 100 meters from the road. And there was a drastic decline of important species, important peatland species such as sphagnum mosses and lichens, which were often replaced by shrubs. Moreover, species that are not typically associated with peatland in the region have also appeared since they were better adapted to the environmental conditions near the road. Those results are not surprising, given that conductivity and pH in the peatland water near the road were much higher than what would be expected in an undisturbed peatland. And this change may be due to increased concentration in ions such as calcium, sodium, and potassium. And what's interesting to note is that these chemical changes were much more pronounced downstream of the road. In fact, roads built with granular materials that come from local rock blasting can become a major source of mineral and nutrients and have a fertilizing effect on peatlands, which are generally very poor environments. It has already been shown that unpaved road can generate significant amount of dust deposit, which can affect acidic and poor environment, such as Arctic tundra ecosystem and peatlands. In our study, however, the fact that a greater impact is present downstream of the road with no apparent link with the direction of the prevailing wind that favored dust transport suggests that the enrichment may instead come mainly from contaminated surface runoff in contact with the road or from groundwater that is passing through the subsurface structure. In addition to that, the spreading of de-icing salts and dust suppressant on gravel may exacerbate this contamination by promoting the transport of contaminants such as sodium, calcium, sodium, and chlorides. Although road-induced water level variation did not appear to be the main driver of change in our study, preliminary analysis of water level data and the existing literature on the subject lead us to believe that a variation of water level of about 10 centimeters on either side of the road, so rising upstream and drying out downstream the road, is enough to affect the plant community. This is why in the next steps of the project, we want to look in more detail to the effect of road on the groundwater general flow dynamic in peatlands, which we'll do using modeling. And these models will enable us to simulate the effect of adding, by example, a culvert or ditches on the hydrology of the peatland impacted by the road. So far, what we can conclude is that roads have a significant impact on peatlands as they cause changes in plant community and create a barrier to groundwater flow. These changes can be seen at distances of up to 50 meters from the road. And the question now is, how do these roadside changes influence carbon sequestration in peatlands? And on a global scale, considering that peatlands store about 1/3 of world terrestrial carbon, there's an expansion of the world network in Boreal ecosystem, as we're now witnessing around the world, constitute a threat to these carbon pools. And finally, we surely want to be able to propose solutions to improve the design and the maintenance of road crossing peatlands in order to better protect these ecosystems. So thanks to the financial partner.